All right, so you're going to be guaranteed one FRQ is going to deal with motion, and you're going to have to know what these things mean. So what does this one mean? We have this integral from 2 to 6 of v of t dt. This is going to be our displacement, right? This is our displacement, or your change in position, right? If you were to think about the fundamental theorem, if we had an object moving along the x-axis, this would be our position on the x-axis at 6 minus our position at 2. So it's just our change in our position from 2 to 6, okay? And so we'd be able to actually rearrange these, like by using the fundamental theorem. And so if you rearrange this and move this x over here in front, you end up getting this value right here. So what does this end up telling us right here? Like C, for example. Like, so think about this fundamental theorem. If we just add x of 2 over, this is going to end up being x of 6, which is just finding our position at time equals 6, right? So that's all that's doing, find your position at time equals 6. And if you had y of 2, this would be motion up and down. So this would be your y position at 2. So this would be like your y position at t equals 2. No, not t equals 2, t equals 6, right? T equals 6. And so realize, though, that you could have motion up and down or left and right. So if you have motion on the x-axis, it's going to be left and right. Up and down would be on the y-axis. And realize you're positive, your velocity is positive, you're either moving to the left, velocity is positive, you're moving to the right or up because your position is increasing. If your velocity is negative, you're going to be moving to the left or down because your position is decreasing, and those would represent positions that are decreasing or increasing on that x-axis. Does that make sense? Okay. So just realize nothing really changes if you're going up and down except for just the direction that you're talking about, like up, but they really work the same exact way. So don't get confused because the object's moving on the y-axis. It really works exactly the same. You find the position the same. It's just a matter of, instead of saying on what interval is the object moving to the left, it'll say on what interval is the object moving down. Okay. All right. What is this one when the absolute value is there? Total distance, right? So this is the total distance traveled. Okay. And so that's you will never use this to find your position, right? So you will never use that because this just doesn't tell you where you are, it just tells you how far you've moved over some time period. It doesn't care whether you move forward or backward. So it doesn't care, you could have moved, 100 miles and your position could have not changed at all. You could have gone 50 miles one way and 50 miles back. Your total distance would be 100, but your displacement would only be 0. Okay, so make sure we understand that. All right, we have this integral divided by the interval. What is this actually finding? Per time, right? So it's our displacement divided by time, which is going to end up being, if we find out how far our position changed divided by how much time it took, that's going to tell us the average of what? Velocity, yeah. Your average velocity. Because basically, how much did our position change divided by how much time? So if we moved 10 meters, or let's say 12 meters in 4 seconds, we on average move 3 meters per second, right? This is telling us how much our position changed in how much time, which is our average velocity, all right? What about this? If we find our change in velocity over time, right? Think about the units on this. This was in meters per second, and we're dividing by seconds. What has units of meters per second per second? So it's the rate of change. So it's the average rate of change of our velocity. But what is the average rate of change of our velocity going to be the same as? Average what? What's the rate of change of velocity? Acceleration. There we go. So this would be our average acceleration. Okay. Realize you could get this exact same thing if you did the integral from 0 to 6. No, not from 2 to 6. Sorry, from 2 to 6 of our acceleration over 6 minus 2. Because realize this is just the antiderivative. The antiderivative of our acceleration is going to be our velocity. So velocity at 6 minus our velocity at 2 divided by 6 minus 2. So our average, and sometimes you might see this instead of, you'll see it like this on word problems. You might actually see instead of 6 minus 2, sometimes they put a fraction out front. So that's how you'll know it's usually an average value of something. It'll be like 1/4 of this. And that's the same thing. So it's finding the average acceleration is the same as the average rate of change of our velocity, right? Because the rate of change of the velocity is the acceleration. So hopefully you're connecting it. Those are the same thing. And through the fundamental theorem, it's the same thing. Okay? Make sure we understand that if we have x of t is position, x prime, the derivative, that's your velocity, and then the second derivative is going to be your acceleration. So if we do antiderivatives, you're just going back the other direction. Okay? All right. So what is the speed? So it's not the velocity. It's close to it. It's related to the velocity. What is it going to be compared to the velocity? No. So speed is just how fast you're going. Velocity is how fast you're going, but which direction. So speed doesn't care which direction you're going. So it's just the absolute value of your velocity. So it's your absolute value of your velocity. So you gotta make sure you understand that, because sometimes the question will ask you what's happening with the speed versus what is happening with the velocity equation. Okay, so make sure we're good with that. All right, so speed is increasing, and sometimes you're asked when speed's increasing. And so speed's increasing, what's gonna have to be true for speed to be increasing? What's gonna be the same sign? Okay, velocity and acceleration, or v prime of t, are the same signs. And this also, when you have to answer these on an FRQ, make sure you are specific. Don't just say, oh, because they're the same signs. You need to make sure that you end up saying that v of t and v prime of t are the same signs. Okay? And remember, v prime of t is the acceleration. All right, so whenever you're considering whether an object is moving towards something or away from something, a lot of times they say, is the object moving towards the origin or away from the origin? Or it says, are the two particles, like we saw in our practice FRQ test, we saw, are the two particles moving towards each other or away from each other? What do you have to consider whenever you're talking about things moving towards something or away from it? What two things do you have to know? Position and velocity. You have to consider the position and velocity. Does not matter the acceleration. It's nothing to do with it, okay, about whether you're moving towards something or away from something. It's just where it is and which direction it's going. And so it's best to draw out and draw out a little number line and see where it is. It's not always going to have you going towards the origin or away from the origin. So I know some students just like to memorize that. Oh, when they're the same signs, I'm moving away from the origin. When they're the opposite signs, I'm moving towards the origin. But really, you need to make sure you understand that it's where the object is, right? So here's the object here, and then which direction it's going on that number line will tell you, because sometimes it might say, is it moving towards another particle? Is it moving towards, its initial position? There's a lot of different things it could ask you there. So you got to make sure you're considering the position and velocity, and don't mention the acceleration. So if you start mentioning acceleration in your explanation, they're not going to give you points, okay? Because it doesn't matter whether you're accelerating. It's like when I throw this object, this pen up in the air, right? The acceleration is always down, but at some points I was moving towards the ceiling. This object was moving towards the ceiling, and sometimes it was moving away from it. So it just depends on where it is relative to the ceiling, and then which direction it's moving, which is velocity is going to tell you that. Okay.